Hello, math nerds. It's the craziest math nerd of all, Kitty Morgan here, talking to you a little bit about what's going to happen on day 2 of calculus. Well, the first day wasn't so bad. I just had to look at graphs and answer questions. And so we know that you can do calculus now because you actually did calculus yesterday. We just didn't put the calculus symbols with it. So we're going to tie that all in for you together. Tie that in together, excuse me, for you today. So yesterday you were asked to find the y values that you're approaching as x went left and right forever. So what we're going to do today is talk about how do you write that in symbols. So you're going to use something called a limit, and the symbol for limit is LIM. So you write LIM, and underneath it you're going to write X arrow wherever you're going. So X arrow, and you are going to the left forever in this example. So if you want to do that, that's negative infinity because that means left forever. And then you write your function here. And you read this, the limit as x approaches negative infinity of f of x. And that symbol means the same thing as you did yesterday. It means what are the y values approaching as x goes left forever. So when you write your answer, you're going to say equals, and then you're going to tell me, does it stop at a particular value? Does it go up and down forever? You're going to answer those questions, okay? But that's how you write the question. For the second one, I bet you can guess how you do this because now we want to ask what the y values are approaching as x goes right forever. So again, we're going to do that limit because we want to know if something is limiting the y values. So that's a limit is something that you approach. Okay, so what are the y values approaching means limit. And now, if you want to go right forever, I bet you can guess what we're going to put there. We're not going to put a negative infinity. We're going to put a positive infinity. And no, you do not have to put that plus for positive infinity. I do it for emphasis because I'm kind of learning. And so when I have to do the negative infinity because that has to be there to go left. But to go right, you don't need a positive or a plus infinity. It's always understood if there's just an infinity that it is positive, but I'm doing that because I'm learning, and that helps me kind of read out, and that kind of indicates to me that's right, like as I'm going right forever. So that's how you take the questions from yesterday and write them in calculus terms. So let's talk a little bit about the answers. You had different kind of answers yesterday. You had down forever, you had down forever, you had up forever, you had a number answer, which meant the graph was chilling out to a certain number, and then you had a repeating pattern where you didn't really approach a one y value. Okay, so how do we answer these infinity limit questions? How do we answer these? So yesterday, and I'm going to the third column, you were asked to find out what happens as x cubed goes left forever. And so the first thing, let's do this. Let's write down what the symbol question would be. So we're going to write the limit as x goes to, I'm going left forever, so that's negative infinity of x cubed. And we actually had an answer there. And that answer was it goes down forever. Well, how do you write answers that say down forever? And that is going to be negative infinity. Oops, sorry. Well, infinity got crazy. So the limit part tells you where the graph, the x's are headed. The answer part tells you what the y's are doing. So that's the answer to a limit tells you what the y's are doing. So when I read this limit problem, I would say the limit as x approaches negative infinity of x cubed equals negative infinity. That's how I read it. But how I interpret it is as the function x cubed, goes left forever, the y's go down forever. Okay? So you can read the symbols, but what you're going to need to do is interpret what that means graphically so you can figure out what the function is doing. Okay? All right, let's try another one. So number 2 was talking about x squared was going right forever. So I'm going to write that question in terms of limits. So the limit as x approaches, I'm going right forever, that means positive infinity, of x squared. So see, like in the first questions, I just wrote f of x because I didn't know what it was, but now I do, so I'm going to write what f of x is equal to, and this graph went up forever, so I'm going to say positive infinity. So if your y's, your answers, your y's, let's write y's. Well, that's not a very good y's, is it? Sorry. The answers are the y's. If your y's go down forever, then your answer is negative infinity, and that means I don't have a stopping place. I'm going down forever. And if it's up forever, the answer is positive infinity. In number 9, the question asks you about what happens to 1 over x as we go left forever. So let's go ahead and do that part. The limit as x approaches, see, every time I say approaches, I write that arrow. That means approaches. Left forever, negative infinity. So I have now said the limit as x approaches negative infinity, or goes left forever, of 1 over x is equal to, and this said, when we talked about this yesterday, we said the y values chill out to 0, and so that's why the answer here is 0. So if you have a number answer, then you just write down your number, whatever it is. So if the graph does chill out to a particular y value, you're going to put that down as your answer, because that's what the y's are doing. Okay, so the answer, the part, I'm going to change colors here for a minute so you can make some emphasis here. So all of this that I've circled in blue tell you like where you're going as far as the x's. That's your left forever, your right forever, your left forever. Okay, that's all your x's. Another emphasis color, let's choose green. We're going there. Go green, get it? Your y's are the answer. So graph goes down forever, negative infinity. Graph goes up forever, positive infinity. The y values approach 0, so your answers are y's. So your limit part tells you about your x, and your answer is your y, because that's what you're approaching. All right, let's go back and grab my red pen one more time. And the last one talks about this repeating pattern, okay? If you have a pattern that repeats and you do not approach a y value, not one y value, we say the limit does not exist. Because a limit is a y value, one y value that you approach. And so many times we'll write that as DNE. That's a weird little N, but anyway. So yesterday in all the trig functions that we talked about, as the function went right or left forever, so that would be, I could write that limit as x goes to positive infinity of cosine. That's one of the trig functions. The y values are not approaching a specific value, and they're not going up or down forever. So I can't give like a infinity answer, because that means I'm going up or down forever. So I just have to say does not exist. Does not exist. And I could have said positive or negative infinity here. It doesn't matter, like right there, because going left or right, they both don't exist. So that's interesting, because you don't have it doesn't chill out to one value, and it doesn't go up or down forever. So we just say that there is no y value that it approaches, and it doesn't go up and down forever. So this will tell us a lot about functions. So welcome to the world of symbols for calculus. And here's some little notes just to know. An infinity answer is to a limit means I don't have a limit. That means I don't stop anywhere. That's what a limit is. It's a stopping value. And the graph is going in a particular direction. So if your limit, the answer to your limit is a positive or negative infinity, it means I don't stop anywhere, but this is the direction that my y values are going. Okay? And that this right here, the last little statement, is you can write a little plus with the infinity or not. It's just for emphasis. So hope this helps. Thank you so much for joining in today, and talk to you soon.